The small block Chevy have always fascinated me. I'm not entirely sure why, to be honest. Maybe because of its sheer ubiquity, maybe because of its democratic approach to horsepower, or maybe because in a world of increasingly complex engines, this thing just refuses to die. When I was a kid tinkering with my dad's tools in the garage, the small block was like this mythical creature that everyone talked about in hushed, reverent tones. You could find one in a junkyard for $200, slap it in anything with 4 wheels, and suddenly you had something that could embarrass cars, costing 10 times as much. What's the first thing that comes to mind when I say American V8? If you're like most people, you probably picture a small block Chevy, and there's a damn good reason for that. Since 1955, General Motors has built over 100 million of these things. 100 million. That's not a typo. That's more engines than Ford has sold F-Series trucks, and those have been the best-selling vehicle in America for like 40 years straight. But here's the kicker. The small block wasn't supposed to be revolutionary. It was supposed to be cheap. Ed Cole had just become Chevrolet's chief engineer in 1952, and he had a problem. Actually, he had several problems. The Corvette was struggling to sell because its wheezy Blue Flame 6 couldn't outrun a determined mailman. Ford was absolutely destroying them in the performance market with their new overhead valve Y-block V8. And perhaps most embarrassingly, Hudson was cleaning house in NASCAR with their massive straight sixes. Chevy needed a V8 and they needed it yesterday. Now Ed Cole was an interesting character. The man was obsessed with making things lighter, simpler, and more powerful all at the same time. Sounds impossible, right? Well, Cole had already pulled off the impossible once before when he helped develop the Cadillac V8 in '49. That engine was revolutionary for its time, using hydraulic lifters and achieving a level of smoothness that made Packard engineers weep into their blueprints. But for Chevy, he wanted to go even further. He wanted to build a V8 that could be manufactured cheaply, modified easily, and stuffed into anything from a passenger car to eventually a Corvette. The development team, and I use that term loosely because we're talking about maybe 15 guys total, started work in early 1953. Cole gave them 18 months to design, test, and prepare for production an entirely new engine architecture. Ford had taken 3 years to develop their Y-block. Chrysler spent nearly 4 years on their Hemi. But Cole was either supremely confident or completely insane. Maybe both. What they came up with in the fall of 1955 was nothing short of genius disguised as simplicity. The 265 cubic inch V8 weighed just 530 pounds, about 40 pounds less than Ford's Y-block. It made 162 horsepower in base form, or 180 with the optional 4-barrel carburetor. Those might sound like rookie numbers today, but remember the old Stovebolt 6. It made 123 horsepower on a good day with a tailwind. But here's where things get interesting. The small block's real innovation wasn't in any one revolutionary feature. It was in how everything worked together. The thin wall casting technique allowed for larger bores without adding weight. The valve train was dead simple with stamped steel rocker arms that cost pennies to produce. The intake manifold incorporated the lifter valley cover, saving parts and weight. Even the distributor was cleverly positioned at the back of the engine, making it accessible but out of the way. And then there was that bore spacing, 4.4 inches on center. Cole insisted on this specific measurement, and the engineering team thought he was nuts. Why not 4.3 or 4.5? But Cole had a vision. He knew this engine would need to grow over time, and that bore spacing would allow cylinders up to 4.125 inches in diameter. That seemingly arbitrary decision would prove to be one of the most important in automotive history. The first small blocks hit the street in 1955, and the reaction was immediate. Hot rodders who had been squeezing every last horsepower out of flathead Fords suddenly had a new toy. And what a toy it was. The engine responded to modifications like an eager pupil. Swap the cam add headers, bolt on a 4-barrel, and suddenly you had 250 horsepower. In 1955, that was supercar territory. But Chevy wasn't done. In '57, they introduced the 283 cubic inch version. Same basic architecture, just bored out a bit. But the real star was the fuel-injected version, 283 horsepower from 283 cubic inches. 1 horsepower per cubic inch. It was a magical barrier that had marketing departments salivating. The ads practically wrote themselves. Now, admittedly, the Rochester fuel injection system was about as reliable as a chocolate teapot in Death Valley. The thing was constantly going out of adjustment, dealers didn't know how to work on it, and most were converted back to carburetors within a few years. But it proved the small block's potential. This wasn't just a cheap V8 anymore. This was a serious performance engine. The aftermarket explosion happened almost overnight. Suddenly, companies like Edelbrock Holley and Iskandarian were churning out performance parts specifically for the small block. Intake manifolds, camshafts, headers, pistons, you name it, someone was making it. Hot Rod magazine couldn't publish tech articles fast enough. Every issue had some new combination, some new trick to squeeze more power out of Ed Cole's creation. And it wasn't just drag racers and hot rodders taking notice. NASCAR teams quickly figured out that the small block was virtually indestructible when built right. You could run these things at 7,000 RPM all day long, and they'd just keep singing. Compare that to the Y blocks, which had an annoying habit of throwing rods through the block when pushed hard, or the Chrysler Hemis, which were powerful but heavy and complex. By 1962, Chevy introduced the 327. More displacement, more power, and somehow still the same basic architecture. The bore spacing that Cole had insisted on was paying dividends. Then came the 350 in '67, 350 cubic inches of American thunder. It would become the most popular displacement, eventually accounting for millions upon millions of units. But here's what really separated the small block from everything else. It wasn't the power, though it made plenty. It wasn't the weight, though it was remarkably light. It was the interchangeability. A cylinder head from a 1955 265 would physically bolt onto a 2004 350. Would it work well? No. Should you do it? Definitely not. But the fact that you could speaks volumes about the fundamental rightness of the original design. This interchangeability created something unprecedented in automotive history, a vast communal knowledge base. Every trick, every modification, every failure was shared, documented, and improved upon. CarCraft magazine would publish a build, and within months, thousands of readers would have tried it, refined it, and reported back. The small block became the Linux of engines, open source in all but name. The cultural impact went beyond just car guys. The small block powered the muscle car era. Camaros, Corvettes, Chevelle Novas, they all ran small blocks. It became the soundtrack of American performance, that distinctive loping idol of a heavily cammed small block. Even people who couldn't tell a spark plug from a drain plug knew that sound meant business. Television and movies amplified the legend. Every cop show chase scene, every teenage rebellion flick, they all featured small block powered machines. American Graffiti, 2-lane blacktop vanishing point. The small block was as much a character as any actor. It represented freedom power and the distinctly American idea that with enough ingenuity and elbow grease, anyone could go fast. But perhaps the small block's greatest achievement was democratizing performance. Before 1955, if you wanted a fast car, you either needed deep pockets or serious mechanical skills. The small block changed that. Suddenly, any kid with a few $100 and a socket set could build something respectable. Junkyard 350, a used Holley 4-barrel, and a set of headers, and you were in business. This accessibility created a feedback loop. More people building engines meant more innovation, more parts development, more knowledge sharing. The aftermarket grew from a handful of companies to a massive industry. By the 1970s, You could build an entire small block from aftermarket parts. No GM components required. Try doing that with any other engine family. The smog era of the 70s should have killed the small block. Compression ratios dropped, horsepower plummeted, and efficiency became the watchword. The 305 cubic inch economy version was about as exciting as watching paint dry. But the architecture survived. The knowledge base remained. And when the horsepower wars resumed in the 80s, the small block was ready. The tuned port injection systems of the 80s, the LT1 of the 90s, the LS series of the 2000s, they all carried small block DNA. Sure, the LS engines were technically a clean sheet design. New block, new heads, new everything. But that bore spacing, still 4.4 inches. Ed Cole's ghost was smiling. Even today, in the age of direct injection, variable valve timing, and cylinder deactivation, the small block soldier on. You can walk into any Chevrolet dealer and order a brand new 350 crate engine. It'll bolt right into that 67 Camaro using the same motor mounts, the same bell housing pattern, the same accessory mounting points. Try that with any other manufacturer. The numbers are staggering when you really think about it. 100 million engines over nearly 70 years. That's about 4,000 engines per day every day, including weekends and holidays since 1955. The tooling has been paid for so many times over that GM probably makes money selling a bare block for $300. But it's not really about the numbers, is it? It's about what the small block represents. In an era of increasing complexity, it remained simple. When other engines required specialized tools and knowledge, it could be rebuilt on a kitchen table. While European manufacturers chased exotic technologies, it just kept doing what it did best, making reliable, affordable power. There's something beautifully American about the small block's success. It wasn't the most advanced engine. The Chrysler Hemi had better breathing. The Ford Cleveland had better flowing heads. Various overhead cam designs were more efficient. But the small block won through sheer persistence and adaptability. It's the automotive equivalent of the 45 Colt, still relevant after all these years because the fundamental design was right. I think about Ed Cole sometimes. He died in 1977 piloting his private plane when it crashed in bad weather. He never got to see the small block's full impact. Never saw the LS engines making 600 horsepower from the factory. Never witnessed the crate engine revolution that put brand new small blocks in everything from kit cars to boats. But maybe he knew. Maybe when he insisted on that 4.4-inch bore spacing, he could see decades into the future. The small block story is really a story about democratization. Before 1955, performance was for the wealthy or the highly skilled. After 1955, it was for everyone. That kid working at the gas station could build a street terror. That farmer could hop up his pickup. That accountant could have a weekend warrior. The small block didn't just power cars, it powered dreams. And honestly, that's what makes it America's most loved engine. Not the specifications, though, those are impressive. Not the racing victories, though there were many. Not even the sheer production numbers, though those are mind-boggling. It's loved because it gave regular people access to extraordinary performance. It turned shade tree mechanics into engineers and parking lot conversations into technical seminars. You know what's funny? Every few years, some magazine publishes an article about the death of the small block. Electric cars will kill it, they say. Emissions regulations will strangle it. Fuel economy standards will make it obsolete. And every time the small block adapts and survives. Variable displacement, direct injection, even hybrid assistance. The basic architecture just keeps accepting new technology like it was designed for it all along. Maybe that's the real genius of Ed Cole's design. He didn't try to build the perfect engine for 1955. He built an architecture that could evolve. Those thin walls allowed for bigger bores. That valve train allowed for roller cams. That block design accepted 4-bolt mains. Every advancement, every improvement, the small block just absorbed it and kept going. Today you can build a 1,000 horsepower naturally aspirated small block. That would have been pure fantasy in 1955. But it's the same fundamental engine, same bore spacing, same deck height, same basic architecture. It's like Cole built a house with a foundation strong enough for infinite additions. Each generation just kept building adding rooms, improving the structure but never needing to tear down and start over. The LS engines proved this beyond doubt. When GM finally did redesign the small block from scratch, what did they keep? The bore spacing, the 90-degree V-angle, the pushrod valve train. All the fundamental decisions Cole made in '53 survived into the 21st century. That's not validation, I don't know what is. And here's the beautiful irony. In an age where manufacturers jealously guard their technology, where right to repair is a constant battle, where proprietary tools and software lock out independent mechanics, the small block remains defiantly open. You can still rebuild one with basic hand tools. You can still modify one without a computer. You can still learn by doing, not by reading encrypted service manuals. That accessibility created generations of engineers and mechanics. Kids who learned on small blocks went on to design engines for GM, Ford, Chrysler, even Ferrari and Lamborghini. The small block wasn't just an engine, it was an education, a mechanical university that accepted anyone willing to learn. No tuition required, just curiosity and a willingness to get your hands dirty. The sound is part of it too. That distinctive small block rumble. It's not the shriek of a Ferrari V12 or the bellow of a big block. It's somehow both aggressive and approachable, threatening enough to command respect, but familiar enough to feel like home. You hear it at every car show, every drag strip, every cruise night in America. It's the background music of American car culture. I remember the first time I really understood what made the small block special. I was maybe 15, helping my uncle rebuild a 350 for his Nova. We had the engine completely apart, spread across his garage floor, like the world's greasiest jigsaw puzzle. And as we put it back together, he explained how everything worked. Not just what each part did, but why it was designed that way. The simplicity was revelatory. No overhead cams to time, no complicated variable valve timing systems, just push rods and rockers and springs. Everything was accessible, everything was logical, everything was fixable. Compare that to modern engines, where changing spark plugs requires removing half the intake system. The small block was designed by people who actually worked on engines for people who actually worked on engines. That's becoming increasingly rare. Modern engines are designed for robots to assemble and computers to diagnose. They're more powerful, more efficient, more capable in every measurable way. But they're not more loved, because you can't love what you can't understand, and you can't understand what you can't touch, modify, improve with your own hands. The small block gave millions of people that opportunity, to not just own performance, but to create it, to not just drive fast, but to understand why, to not just buy horsepower, but to build it. That's a fundamentally different relationship with machinery. It's the difference between being a user and being a participant. And that participation created community. Small block guys would help other small block guys. Knowledge was shared freely because everyone benefited from collective advancement. Forums, websites, magazines, books, the amount of information available about small blocks dwarfs any other engine family. You can find build recipes for any combination, any application, any budget. Want to make 300 horsepower for $2,000? There's a recipe. Want to make 800 horsepower for $20,000? There's a recipe for that too. This community aspect multiplied the small block's impact. Every successful build inspired others. Every innovation was quickly adopted and improved. Every failure was analyzed and avoided. It was crowdsourced engineering before anyone knew what crowdsourcing was. The hive mind of millions of enthusiasts pushing the design further than any corporate engineering team could have imagined. Even the failures were instructive. Everybody knew somebody who'd windowed a block with too much nitrous. Everyone had heard about the guy who spun a bearing because he didn't check clearances. These weren't just cautionary tales, they were teaching moments. The small block community learned collectively from individual mistakes. Try finding that kind of institutional knowledge for any modern engine. The racing impact can't be understated either. From circle tracks to drag strips, from road courses to Bonneville, the small block competed everywhere. And it didn't just compete, it dominated. Not always through superior technology, but through reliability and development. While other engines required specialized parts and expertise, the small block just needed someone who understood the basics. This racing development filtered down to street engines, that cam profile that won championships. Available at your local speed shop, those cylinder heads that set records, reproduced in aluminum for half the price. The technology transfer was immediate and affordable. Racing improved the breed and everyone benefited. Even today, with LS engines making power that would have been incomprehensible. In 1955, the basic formula remains unchanged. Displacement plus compression plus cam plus heads equals horsepower. No magic, no proprietary technology, no unobtainium parts. Just sound engineering principles applied consistently over decades. The crate engine phenomenon deserves special mention. GM's decision to sell complete engines directly to consumers was revolutionary. Not rebuilt, not remanufactured, but brand new engines with warranties. You could order a ZID 4 350 and have professional grade power delivered to your door. It was like mail order horsepower. And it worked because the small block was simple enough to install without professional help. This democratization extended beyond just hot rodders. The small block powered boats, generators, industrial equipment, you name it. Its adaptability made it the default choice for any application requiring reliable V8 power. Marine versions powered everything from ski boats to offshore racers. Industrial versions ran pipeline pumps and generators. The same basic engine that powered your neighbor's Camaro might also power the backup generator at your local hospital. That versatility came from the fundamental rightness of the design. Not too big, not too small, not too complex, not too simple. Powerful enough to be useful, efficient enough to be practical. It occupied a sweet spot that no other engine quite matched. Big blocks were too thirsty, sixes were too weak, imports were too complex. The small block was just right. The cultural impact extends beyond cars entirely. The small block became a symbol of American ingenuity and accessibility. It represented the idea that performance wasn't reserved for the elite. That speed wasn't just for the wealthy. That with knowledge and effort, anyone could participate in the performance world. It was egalitarian in a way that no European exotic could ever be. Think about the timing too. The small block arrived just as America was entering its automotive golden age. The interstate system was beginning. Suburbs were expanding. Cars were becoming central to American life. And the small block was there to power it all. From grocery getters to street racers, from work trucks to weekend toys. It was the right engine at the right time for the right country. The modifications culture that grew around the small block influenced everything. Those companies that started making intakes and cams, they grew into massive corporations. That knowledge base of what works and what doesn't. It became the foundation for modern hot rodding. Those kids who learned to port heads and degree cams, they became the engineers and designers who shaped modern performance. Even the language of performance was influenced by the small block. Bore and stroke, compression ratio, duration, and lift. These terms entered the mainstream because millions of people were building small blocks. Car guys could communicate in specifications because they all spoke small block. It was a shared vocabulary that transcended brands and models. The small block also proved that simpler could be better. While other manufacturers chased complexity, Chevrolet refined simplicity. Overhead cams might have been technically superior, but they were also more expensive, more complex, more difficult to modify. The small block's pushrod valve train might have been old-fashioned, but it was also bulletproof and infinitely tunable. This philosophy influenced American engine design for decades. Even as technology advanced, American V8s remained relatively simple and accessible. The modularity, the repairability, the modifiability. These became expected features. The small block set the template, and others followed. Even Ford's Windsor engines borrowed heavily from the small block playbook. You know what really gets me? The small block succeeded without any revolutionary technology. No overhead cams, no turbochargers, no variable valve timing, at least not originally. Just solid engineering applied intelligently. It's a reminder that innovation doesn't always mean complexity. Sometimes it means getting the fundamentals so right that everything else becomes possible. And those fundamentals were all about manufacturing efficiency and service accessibility. The small block was designed to be built cheaply and fixed easily. Every decision from the stamped rocker arms to the integral lifter valley reflected this philosophy. It wasn't just an engine, it was a manufacturing philosophy made manifest. That philosophy created unexpected benefits. Because the engine was simple, it was also light. Because it was light, it was also efficient. Because it was efficient, it could be made powerful without excessive fuel consumption. Each advantage built on the previous, creating a virtuous cycle of improvement. The longevity is perhaps most impressive. Most engine designs last maybe 15 or 20 years before being replaced. The small block architecture lasted nearly 50 years in production. And if you count the LS engines, which share that crucial bore spacing, it's still going strong at nearly 70 years. That's not iteration, that's evolution. Each generation building on the previous, maintaining compatibility while advancing capability. This longevity created something unique in automotive history. Grandfather, father, and son could all work on small blocks together. 3 generations sharing knowledge across decades. The engine that Grandpa put in his 57 could teach lessons applicable to Dad's 87, which could inform Junior's 2007. That continuity of knowledge is priceless and irreplaceable. Modern manufacturers chase clean sheet designs. Every decade brings new engines with new technologies requiring new tools and new knowledge. The small block proved that evolution could trump revolution. That careful refinement could outperform radical redesign. That maintaining compatibility could create more value than chasing novelty. I think about what we've lost in the rush to modernize. Yes, modern engines are more powerful, more efficient, more capable. But they're also more distant, more mysterious, more appliance-like. You don't rebuild a modern direct injection turbo 4. You replace it. You don't modify it. You reflash it. The mechanical intimacy is gone, replaced by digital abstraction. The small block represents the last era when regular people could fully understand their engines. When modification meant wrenches, not software. When improvement came from knowledge, not just credit cards. It's not nostalgia to recognize what we've traded for progress. It's honesty. But here's the thing, the small block isn't actually gone. You can still buy one. You can still build one. You can still learn from one. In a world of increasing complexity, it remains defiantly accessible. That's not just impressive, it's important. It's a reminder that not everything needs to be complicated to be good. The numbers tell one story. 100 million engines, 7 decades of production, countless wins, innovations, builds. But the real story is harder to quantify. It's the kid who learned mechanics on a junkyard 350. It's the racer who won championships with clever development, not cubic dollars. It's the family that bonded over a rebuild. It's the community that formed around shared passion. That's why the small block is America's most loved engine. Not because it's the best by some objective measure, but because it invited everyone to participate. Because it democratized performance. Because it created opportunity where none existed. Because it proved that with the right foundation, anything is possible. Ed Cole probably didn't envision all this when he sketched out that first design. He just wanted a good engine that could be built cheaply and would last. But sometimes that's enough. Sometimes getting the basics right creates possibilities you never imagined. Sometimes simplicity enables complexity. Sometimes an engine becomes more than just an engine. The small block became a teacher, a community builder, a dream enabler. It became the mechanical embodiment of American optimism. The idea that with knowledge and effort, anyone could go fast. That performance wasn't reserved for the privileged. That horsepower was a democratic right, not an aristocratic privilege. And you know what? In a world of increasing restrictions, regulations, and complexity, that idea feels more important than ever. The small block reminds us that accessibility matters, that understanding matters, that participation matters. It's not just about going fast, it's about knowing why and how. It's about connection not just to machines, but to knowledge and community. So yeah, the small block Chevy is America's most loved engine. Not was, is. Because love isn't about perfection, it's about connection. And no engine has connected more people to performance, to mechanical understanding, to community than Ed Cole's masterpiece, 100 million engines. But more importantly, millions of enthusiasts, all speaking the same language, all sharing the same passion, all building on the same foundation. That's a legacy worth celebrating. That's an achievement worth recognizing. That's why 70 years later, we're still talking about bore spacing and compression ratios and cam profiles. Because the small block didn't just power cars, it powered dreams. And in America, that's about as good as it gets. The future probably belongs to electric motors and hydrogen fuel cells and technologies we haven't imagined yet. But the past and a good chunk of the present belongs to the small block, to push rods and carburetors and mechanical simplicity, to the idea that performance should be accessible, understandable, achievable by anyone willing to learn. That idea will outlive any specific engine, but it found its perfect expression in the small block Chevy. 4.4 inches of bore spacing, 90 degrees of V-angle, 2 valves per cylinder, pushrod actuation, simple architecture, infinite possibility. That's not just an engine specification, it's a philosophy. And that philosophy is why the small block isn't just respected or admired, it's loved. Long may it rumble.